5.3. Finish. And examples in main. New package. com.android. New class. Main. Finish. New class. EXIPRS. Now, so which one is this going to be? This is going to be exam objective. .2 create and use for loops, including enhanced for loops. Now I'm going to go to examples. Static void ex1. So a for is for loops. So comment. A for loop consists of 3 distinct parts: the initialization statements, termination condition, and the update clause. Now, so very simple one here is for int I is equal to 0, I is less than 5, I plus plus, I is I. So what is what? So each part is separated by a semicolon. Okay, so I equals 0 is the initialization. Statement. I less than 5, termination condition. As soon as not true, loop terminates. And I plus plus is the update clause. So here's a couple more rules. You can have as many initialization statements as you want. Okay, but they must be all the same data type. Okay, so we're going to do a loop. I'm going to go for int I is equal to 0. I can do another one. J is equal to 1. M is equal to 2. Semicolon. Now we don't have the for loop, so there we got. So here we have 3 initialization. So here we are initializing 3 variables, I, j, and m of type int. Now, the termination clause comes second. Okay, you can have only one termination clause. Okay, so on this one it's going to be as long as I is less than 4. Okay, and one termination clause. In this case, as long as I is less than 4. Okay, so the second statement you have in your for loop, you can only have one thing. Okay, and you can have as many update clauses as you like. You can have as many update clauses as you want. So I will go I plus plus, j minus minus, and plus plus, sorry, plus plus m. Now in that situation it's no harm to put in a space. Or you can even split them over 3 lines. You can do something like this. Okay, so you can clearly see you have a loop there that's made up of 3 distinct parts. All of these guys here, you've declared ints, so that means they have to be all ints. Okay, you've only so this is initialization. This is the exit clause, termination condition. And this is the update clause. Initialization, many, termination condition, only one allowed. The reason you only allow one, let's say if I said I is less than 4, j is greater than, or j is greater than minus 4. You wouldn't know which one to do first. Okay, so there's only one way to get out of the loop. There's many ways to enter it, but there's only one exit condition. The exit condition is the second part. Is everyone okay with that? Yeah? So inside the for loop, I can just go print off I is plus I, j is plus j, and m is plus m. So each time it's going to add 1 onto I. Each time it's going to take 1 away from j, and each time it's going to add 1 onto m. Print it out. Go to main. So there it is. It starts off at, now it only goes 4 times because what's controlling how many times you're doing it? It's I that's controlling it. So it starts off at 0. 0, I is 0, I is 1, I is 2. Oops. It's the wrong one, sorry. This one here. On multiple conditions. So I is 0, j is 1, m is 2. Okay, I is 0, j is 1, m is 2. Then it goes up by 1, j goes down by 1, m goes up by 1. Okay? Now when you're doing something like that, that can be often hard to follow. Because you have 3 different variables that could be doing 3 different things. Okay? Yes, it does work, but I wouldn't go putting any more than 3 as a maximum there. If you put any more than 3 in there, you start to lose track, and it gets too complicated. Alright? So yes, you can do that, but I wouldn't go beyond 3. Because it just makes things more complicated, right?
Termination condition be equal sign.
Yeah. It can be this.
Oh, just another sign?
No.
Oh, yeah, okay.
Can't be that, because what's that doing? That's assigning 4 to I.
And just another example, could you have some condition that when I divide j in added up equals?
Oh yeah. You can have that. Yeah, you can have that. You can. It doesn't have to be just say I is less than 4. You could say I plus j plus m is greater than 10. Something like that. Now, I don't know how many times that's going to go. It doesn't go at all. Because it's greater than 10. So great. Hold on a minute. So while it's less than 10, while I plus j plus m is less than 10, right, there it is. So while it's but it's never going to be it's never going to be exactly 10. Is it?
You made 3 here instead of 10.
Yeah, 3 it is going to reach because it's going to be 1 and 2. Because it can reach it.
It works anyway, right?
Yeah.
I didn't know whether you could get any.
So we just say I is less than 4. I is less than 4. So I is the one that's controlling it. But it can be a combination of I, j and m. Yeah, no problem with that at all. Okay. So now it's important to remember that I, j and m are only available inside these curly brackets. Okay? So this is the end of the for loop. So here, the variables I, j, and m are only available inside the for loop curly brackets. Okay, so if I try to go I outside brackets is plus I get an error. Yeah? Does that understand that? Because it's a local variable. I, j, and k are local to for loop. I, j, and m are local to the for loop curly brackets. Okay? They're not accessible outside those curly brackets. So check that one out. Sorry? Yes, I suppose smoke time. Smoke time. So I'll pause it. So as I said, you can have many initialization as you want. Int I is equal to 0. So that's int I is equal to 0, j is equal to 1, m is equal to 2. Okay? So that is creating and initializing 3 variables that are only visible inside for loop. Does everyone understand that? Yeah? Now, So you can have, as I've said, you can have many initializations. You can have as many update clauses as you want. You can only have one termination. So think of it this way, one exit. That's it. Alright? There's only one way out. Which makes sense. You can't have multiple ways to exit a loop, because how do you know which one it's going to use? Okay? Now, it is possible to put an if statement in here. If it's something, do the, exit this way, else exit another way. That's okay, because that's still only one exit condition. Do you understand that? Right? As long as you have one exit condition, you'll be fine. So it is possible to have a method call inside here that's could have choices, or you can actually put an if statement inside there as well. Okay, as long as it produces one answer. Right? So there is only one way out. Okay. Now, so the variables I, j, and m are no longer available outside, are not available outside of the loop because they're purely local. Now, if I come along here, I'll do int k is equal to 9. Okay. So, and then I go for k is equal to 0, k is less than 3, k plus plus. Now, I don't need an int here because we're not declaring a new variable. We're using the existing variable k. So what we're doing here is we're giving k a new value of 0. Does everyone understand that? Okay, so we're using an existing variable. Sorry, I put it in here. You can use existing variables that are declared outside of the loop. Okay, that means that after the loop executes, k will be available outside of the loop. Alright, so inside the loop, I'm going to say k inside loop is press k, and then outside the loop, final value for k is question. Right, so this loop is going to go a set amount of times. It starts off. What's it going to print off? What's the final value of k going to be? This one here, final value of k. What's the final value of k going to be? 9?
9.
This looks like 9, but 13.
So 9, someone said 9, someone said 13. Huh? Right. I'm going to say something, but I'm not going to say it for fear I'm wrong, to be honest. Okay, I'm fairly certain what it is going to be. Okay? And it's none of those.
That's a good job, so
Right, no. Right. It is going to be not 9, not 13, but 3. Because now I could have made it harder, and I could have asked you what's inside of it. So now when it comes into the loop, it changes k to 0. Now this variable k is available outside of the loop. Alright? So if you change it inside here, the changed value is going to be reflected outside here. Alright? So it comes in here, k is equal to 0, k is less than 3, k plus plus. Okay? So k inside the loop is, so it's going to go, it'll print off k, then it's going to increment it. So to print off 0, then it goes to 1. 1 is less than 3. K inside the loop is 1. Then K plus plus becomes 2. K inside the loop is 2. It's only at that point, so it prints off 0, 1, 2. Then it increments by 1. Increments by 1. It won't print off 3 inside the loop. It'll print off 3 outside of the loop. Okay, so the final value is 3. Now if I did this the other way, so if I change that, what's that going to print off inside the loop? So I've changed from K plus plus to plus plus K.
1, 2.
So it's going to print off what?
1, and that's 2. And so 5 now will be 2.
Okay, so it goes 0, 1, 2. This guy here, alright, that only executes after it does this. Okay? That happens after it does whatever's inside the curly brackets. Okay? So it doesn't matter if it's plus plus K or if it's K plus plus. It's still going to give the same answer. Because the third part, this part here, this is the third part, that is always done after whatever the code is in here. So it prints off K inside the loop is K. The initial value is 0. Then it increments K by 1. So it doesn't matter if you go K plus plus or plus plus K. It's still going to be, it's not going to increment itself till it prints off K inside loop is K.
But sorry, one question. Curly brackets.
Yep.
What happened when curly brackets stay in curly brackets?
No. No. If you create something inside the curly brackets, then it stays inside the curly brackets. If you have something created outside the curly brackets and you change it inside the curly bracket, it's changed everywhere. Okay? So it's only what's created inside the curly brackets stays inside the curly brackets. Okay? So that's local variables. But if you change a variable that was created outside the curly brackets, if you change it inside the curly brackets, it's changed everywhere. Yeah? Okay? K will be available outside of the loop and the value will have changed. Now, and as well here, the update clause is executed only after the code in the curly bracket executes. Okay, so the sequence printed here is K inside loop is 0, K inside loop is 1, K inside loop is 2, final value for K is 3. Is that okay? Now, the beauty of for loops is that you have a lot of control of them. You know exactly what's going to happen at the start. You're going to know exactly how they're going to finish. You know exactly what's going to happen each time inside the loop. With the do while and a while, you're not guaranteed. It's more kind of you're flying by the seat of your pants. Okay? With the for loop, these three guys control everything. So if you look at the top of it, you know exactly right. We're starting off at 0. It goes as far as 3. It goes 3 times. Alright? With the while loop, you could have a load of code inside it, and all sorts of fancy shit could be happening inside it. You've no idea what's happening. Okay? But with the for loop, now, to make things a small bit more complicated, there's nothing to stop you inside of the loop doing something like this. Now, you're meant to do this, but you can't do it. What happens to that loop? It's going to be infinite, because every time it goes forward, it goes back. Right? See? It goes on forever. If that ever happens, just click on the little red button there. That terminates it. Now, it's not a good idea to go using pluses and minuses inside the for loop. You should put all your stuff that's going to be plus or minus up here at the top. Okay? So, you can do this. Use incrementers and decrementers inside loop, but not recommended. Here, this will be an infinite loop. Now, of course, you can have anything happen inside a loop, okay? And all that happens is that instead of the code running once, it's going to run the amount of times the loop is going to go. So if I have a method called print me, and I'm just going to go okay, so print me method called. So I can go here, print me. Okay, so it just calls the print me method 4 times. Does everyone get that? There's nothing really too complicated with that. If you want to create 4 dogs, go inside here, new class, there's a dog class, and I go that creates 4 new dogs. Now, as soon as it creates them, you no longer can access them, but that's creating 4 new dogs. Sorry, not 4, 3. Okay, so calls method 3 times, creates 3 dogs. So you can have an array. You want to populate the array with 3 dogs. That's how you do it. Yeah? Right, now okay, so I'm just going to show you this guy, for. Now this looks strange, but that's legal. Okay? Okay, so just going to print off nothing here. Now that's an infinite loop because it enters. What happens here is if you don't put any entry clause or initialization clause, all that happens is it's just going to go straight into the loop. Right? It's going to go straight into the loop. We have no exit clause. We have no update clause. So yes, you can do that, but that will produce an infinite loop. Right? Can you think now? I'm not saying a good use or a bad use. Could you imagine some usage for that? I can. I'm not saying necessarily good use.
If you need to run always and inside this loop you have another like loops or commands.
Yeah, but is there anything in particular you can think about that you see it virtually every day? There's always something to use about it.
Like the time never stop.
Creating viruses. There you are. Okay? It's never ending. There you have a little bit of a virus construct yourself. It just keeps on reproducing. That's all it does. And there could be all sorts of nefarious, horrible code that's doing all sorts of shit. There it is. Bit of virus code. If you want to keep something running as well continuously, yes. There isn't too many things you're going to want to keep running.
Antivirus.
Sorry?
Antivirus, yeah. Just keep running.
Yeah, no, shouldn't be.
Or anytime scanning.
No, because if it does, I remember from time working in there, it can't be running constantly, because if it's doing that, it's classified as a virus. At least it was where I was working. So can't be that service that can be shut down. Alright? That's basically a service that can't be shut down. Keeps on going. Okay, and that's what a virus is. It's something that keeps on multiplying, making copy of itself, and you can't stop it. All it does is just make more viruses. Okay? So this is a loop. This is the simplest loop construct. For a loop construct. With no initialization, with no part at all. So this will just enter and become an infinite loop. Now you have to put in 2 semicolons. Okay. Every for loop has to have at least 2 semicolons in it. Sorry, a maximum of 2 semicolons in it. Okay, so every for loop only has 2 semicolons in it. Now, that means if you have an initial value for something, so let's go back to, we're going to modify this slightly. So I'm going to say k, which I've already given the value, k is equal to 0. Let's say k up here. Yeah. Oh, I have that inside the loop already. Do I do too? No, I don't. Oh yeah, that's unreachable code. Yeah, good question. Why is that giving me an error? I have defined int k is equal to 0 up here. Works fine. This guy won't work because it's after here. Why is that? Well, it's unreachable code, because if that's infinite, that means anything after an infinite loop can never happen. Okay? So if the compiler senses you unreachable code, it will not compile. Okay, so that's unreachable code, so I'm going to comment out the infinite loop. So take this guy out. Now, you can, so I'm going to do this. So if I do this, now, sorry?
It's fine. You already initialize k.
Because I've given k 0 here, or you can say it's 5. Okay, so that means that this loop starts off at 5. So we don't need an initialization part. As k already exists and has a value of 5. So it's going to go 5, 4, 5, 6, 7, 8, 9. Okay, it's going to go 5, 6, 7, 8, 9. So that's why so k is k, and it's 5, 6, 7, 8, 9. And the last value for k will be outside loop. K is 10. Okay, and here ended the lesson for today. Alright, now we'll get those loops finished. Actually, we might even get the full chapter finished tomorrow, because there is only while, do while, and enhanced for loops, and we've done a lot of them, so we should be okay with them. So we'll probably get maybe even chapter 5 finished tomorrow, and then we'll be 2 or 3 weeks on the next chapter. The next chapter is inheritance. Alright, there's a lot in it. So I'm going to save that. I'm going to stop the video. Alright, so we're doing for loops yesterday. So just to recap. So the simplest form of for loop is this guy here. You don't have any of attributes at all in it. Now that's going to be an infinite loop. So that is just going to enter, and it has no initialization. It has no check. It has no update clause. So that means that is going to be an infinite loop. Okay, so you don't actually have to put anything in between any of those in a for loop. Now, so that means, for instance, here I said k is equal to 5, so I didn't bother putting in the initialization part because k is already at 5, so it starts at 5 and it keeps on going until it's greater than 10. Okay, now, so that's static void ex1. So I'm going to go static void ex2. Now, what is this? This is nested loops. Okay, nested loops. Now, nested for loop, I should say. So nested for loop is a loop inside a loop. Fairly simple. So we're just doing here for int I is equal to 0, I is less than 3, I plus plus. And inside that I can go for int j is equal to 0, j is less than 4, j plus plus. So if I go inside here, I go I is I, j is plus j. Okay, so that means it's going to print off 0, 0, 0, 1, 0, 2, 0, 3. 1, 0, 1, 1, 1, 2, 1, 3. 2, 0, 2, 1, 2, 2, 2, 3. 3, 0, 3, 1, 3, 2, 3, 3. Yeah? Yeah. Okay. So just to prove that it does. Oops. Yeah, hold on.
In j equals 0, I less than.
No. Hold on a minute. Hold on. Stop it now. Okay. So for int I is equal to 0, I is less than 3, I plus plus. Okay. For j is equal to 0, j I I less than 4.
Yes.
Okay. It's keeps on going. Okay. Alright. There we are. Okay. So you will have a total of 12. You'll have 12 lines printed out. Okay. So I is 0. So you have 0, 0, 0, 1, 0, 2, 0, 3, 1, 0, 1, 1, 1, 2, 1, 3, 2, 0, 2, 1, 2, 2, 2, 3. Is everyone okay with that? Yeah? Right. Now, nested loops, I wouldn't go any further than a loop inside a loop. You start putting loops inside loops inside loops, they're too difficult. Okay? You lose track of it. Simple as that. Alright? And you could even have a situation where you have a few conditions inside here, this part, a few conditions inside here, a few conditions inside here, a few conditions inside here, and then you have another loop. There's too many things you have to keep, too many balls in the air. Alright? It's too hard to keep track of stuff. Alright? So, yeah.
Can I ask you, like, I asked you a month ago, you said later on you will show. Like, remember you was giving just like to make square from with stars, and can you show how and explain this? Actually, I found actually no explanation.
Yeah, well, I have to think about it. I can't just show it to you off here because there's no way I'll be able to do it out up here. Okay, so I will, but not today. Alright, so that's a loop inside a loop. Alright, so one thing you can use a nested loop for, you can use it when you're dealing with two-dimensional arrays. Alright, so I'm going to create 3 arrays of strings. Okay, so I'm going to go string names is equal to Harry, George, and Mary. Then we get string names 2 is equal to Laura, Michelle, and column. String names 3 is equal to Patsy, Jack, and Nick. Now, so that is 3 one-dimensional arrays, each of size 3. Okay, so I'm going to create a 2-dimensional array. Okay, so I'm going to go string 2 square brackets to make a 2-dimensional array. I'm going to call this all names is equal to. Now, a 2-dimensional array is an array of arrays. So we've got 3 arrays. So it's going to consist of, our first row is going to be names. Our second row is going to be names 2. Our third row is going to be names 3. Okay, so this is a 2-dimensional array. Which is an array of one-dimensional arrays. One-dimensional string arrays. Okay, So names the first row, names 2 the second row, names 3 the second row. Okay. Now, so what we want to do, we want to create a nested for loop that's going to increment over all of those names. It's going to print off Harry, George, Mary, Laura, Michelle, Colin, Patsy, Jack, Mick. Yeah. So for a start, anyway, we have to go through the actual. So we go for int I is equal to 0. I is less than all names dot length. That's the outer loop. Now, so that's going to go 3 times. Okay, that's going to go 3 times. Just bring up my pen. Okay, so that's going to go 3 times. So it's going to go through, it's going to say, it's going to go 1, 2, 3. Okay, so that's for going through each one of the arrays. And then we want to go, so that goes through each one of the rows. Easiest way to say. Okay, that's going through the rows. Alright, so it's going to go 3 times. Now we want to go through the columns, which is also 3 times. Now I don't say 3, because if you use that structure, that means your array can be any size you want it to. If I just say 3, it can only go through a 3-dimensional array of 3 rows. Yeah? That's why it's always better to do that when you're going through it. And its length when you're dealing with arrays, which is a property, and if it's in array list, it's size, and it's a method. Okay, that's the method of Iris. Right. So now the inner loop will also print out 3 times. But before we do that, we're going to say what row we're on. Row plus I. Okay, that's going to say which row we're actually on. So it's going to say row 0, and then it's going to print off Harry, George, Mary. Row 1, it's going to print off Laura, Michelle, Colin. Row 2, Patsy, Jack, and Mick. Now, if I want to refer to the first row, okay, if I want to refer to the first row, how we refer to the first row is all names 0. Okay, that refers to the first array. Okay, that refers to the first array, which is that guy. All names 1 refers to that guy, and all names 2 refers to that guy. Yes? Okay? So, hi John. I got you, Mr. Grant.
Did you get them?
Yeah, you're sorted, yeah. Just needed this.
There's 3 of them, did you get?
Yeah, I did, John. You're all hunky dunky for it. You're sorted.
I brought them in just in case.
Yeah, oh, yeah, that's good, yeah. I'll take a picture of them just to be sure later. Okay.
Alright.
Yeah. So now, so that means if I go all names 0 dot length, so if I do this, all names 0 dot length, okay, all names 0 dot length, that's going to get us a length of 3. All names 1 dot length, that's going to give you the amount of elements in the second row. All names 2 dot length. Oops. All names 2 dot length, it's going to give me the amount of elements in the third row. Are you with me so far? Yeah? So, what we need to have inside here is we need to do something like this. So we can see that it goes to 0, 1 and 2. Alright? So the number's gone up by 1 each time to signify which row you're on. So, change my code here a bit. So I'm going to go for int j is equal to 0. Okay? So I go all names dot length. Okay? And then we go j plus plus. Now, so why is that giving me? Trying to see why is that giving me an error. Oh yeah, sorry, j is less than. Okay, so j starts off at 0. So all names I dot length. So it goes into our array. For int I is equal to 0, all names dot length, that's going to be 3. Okay, so first row, it's going to print off row 0. Okay, it goes into here. Int j is equal to 0. J is less than all names I. So we're in the first row. Okay, I is 0. So you change that to 0. Int j is equal to 0. J is less than all names 0 dot length, which is 3. So it's going to print out 3. It's going to do inside here. It's going to do this 3 times. Okay, so whatever I'm doing inside here, I'm going to be doing it 3 times. If it's the second row, that's going to be 1. Still 3, length of 3. If it's the third row, that's going to be 2. Okay, the third row, and we want to print off Patty, Jack and Mick. The first row, we want to print off Harry, George and Mary. The second row, we want to print off Laura, Michelle and Cullum. Okay, so how do we access these elements? So we're inside here. We're going to go SYSO. Name is. So I'm going to say all names. We go I, J. Okay, so first name is going to be 0, 0. Second name is going to be 0, 1. Third name is going to be 0, 2. Next line is going to be 1, 0, 1, 1, 1, 2. Next line after that, it's going to be 2, 0, 2, 1, and the final one is going to be 2, 2. Okay, so I'll print it out, see what happens. There we have it. So row 0, name is Harry, name is George, name is Mary. Row 1, name is Laura, name is Michelle, name is Cullum. Row 2, name is Patsy, name is Jack, name is Mick. Okay, so what can you use nested for loops for? Going through a 2-dimensional array. Now, as I said, as you come in to do more advanced Java, you'll be using nested for loops Very rarely. Okay? Because there's plenty of other methods and structures that will do all this for you. Okay? Now, nested for loops are grand, but as I said, the one major problem is that they're complicated. Alright? And it's too easy to make a mistake in. Alright? So, I wouldn't even bother trying to do a for loop inside a for loop inside a for loop, because let me just show you what you can end up with. So, for int I is equal to 0, j is equal to 4, m is equal to 7, I is less than 5, I plus plus, j minus minus, m plus equals, plus equals 5. Come on. You can do stuff like that. Okay, that's one loop. Then we have another loop. For int a is equal to 0, b is equal to 45, c is equal to minus 14, and you can go a plus plus, or sorry, a is less than 60, and then I can go a plus plus, b minus minus, c equals multiply by 2, and we can have another loop. For int num is equal to 4, num2 is equal to 56, num3 is equal to 0, num is less than 100, num plus plus.
Sorry, so where c equal.
Yeah, that's wrong. Okay. Now, good luck trying to figure that out. Alright. Could ask you a question. What's going to be the final values of I, J in A, B, C, num, num2, and num3? Good luck trying to figure that out. Alright? They're all interdependent. Alright? I mean, it's a nightmare. Right? But if you're using nested for loops, you could quite easily end up with something like that. You could spend the whole day trying to figure it out. I wouldn't give you that as an assignment because it's too frustrating. Alright? Now I'm not going to even run that because will it be infinite? I don't know. Let me just see. And it's very easy to end up with an infinite loop as well, by the way. Let me just see. Yeah, print me. No, it's not infinite. Anyway, it's just so nested for loops. Yeah, grand, but don't overuse them. Any questions on that? No questions? So as I said here, I'm going to put in, don't overuse these lads. As can get needlessly complicated.
Is there going to be any questions in exams like this?
Oh Jesus, no. Couldn't. No, because Stefan, that'll take you a week. Well, it'll take you the rest of the day to figure it out. You could do a whole exam on that. So, no. You will be asked a nested loop, alright. They won't ask you much about the nested loop because nested loops take a fair while to long out, and technically you should be able to answer every question in 2 minutes. So, but that's just beyond the too complicated. Okay. Anyway, that is for loops finished. So I'm going to save that recording.